Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover Taylor's series of hyperbolics centered at a equals 0, or really their Maclaurin series. So I'm going to find the Maclaurin series of the hyperbolic sine of x and also the hyperbolic cosine of x. And what I've done here is we know that the hyperbolic sine of x is e to the x minus e to the negative x over 2, and the hyperbolic cosine is the same thing except a plus instead of a minus. You know, this being the odd function, this being the even function of e to the x. So I also found the hyperbolic sine of 0, so e to the 0 minus e to the negative 0 over 2, so 1 minus 1 over 2 is 0. And then similarly, the hyperbolic cosine of 0 is e to the 0 plus e to the negative 0 over 2, or 1 plus 1 over 2, which is going to give us 2 over 2, which is equal to 1. Now I need these values at 0 because I'm going to build the Maclaurin series, which is going to, I need to know the values of the function and also the derivatives at 0. So let's go ahead and start out with the hyperbolic sine function. So I know if f of x is equal to the hyperbolic sine function, what I'm going to need is the derivative. So I'm going to need what is f prime of x, what is f double prime of x, what is f triple prime of x, and then eventually I'm trying to hope to find some kind of pattern to this. Now a lot of times we'll say n of x, but with your trig functions, even the hyperbolic trig functions, you'll see that you're actually going to get, I don't want to spoil it. So what I know is the hyperbolic sine is the derivative is going to be the hyperbolic cosine of x, and the derivative of the hyperbolic cosine of x is the hyperbolic sine of x, and the derivative of the hyperbolic sine of x is the hyperbolic cosine of x. Remember, they behave very similarly to the trig functions, except the trig functions bounce back and forth between plus and minus, and these ones don't, so they're actually a lot more well-behaved. So what I know is I can see that it's going to jump back and forth between the hyperbolic sine and the hyperbolic cosine, so I can't just write this as one piece. What I can see is the function, which we'll think of as the 0th derivative, and the 2nd derivative, and the 4th derivative, and the 6th derivative. What I can see is at the even derivative, so I'm going to say 2n here, it's going to be equal to the hyperbolic sine of x. And when the derivatives are odd, so 2n plus 1 of x, you're going to have the hyperbolic cosine of x. So that's the same thing when you're trying to do the Maclaurin or the Taylor series of your trig functions, is you're going to have to break this into its even and odd parts because you're going to have it bouncing back and forth between sine and cosine. So now let's evaluate these things at 0. So what is f of 0? Well, the hyperbolic sine of 0 we just found is going to be equal to 0. And then what is f prime of 0? Well, that's the hyperbolic cosine of 0, which is going to be equal to 1. And then, f double prime of 0 is going to be back to 0 because it's hyperbolic sine. And then the triple prime of 0 is going to be equal to 1. So what I can see is this is going to bounce back and forth between 0 and 1. So the odd derivatives, 2n of 0, is going to be equal to 0. And then the evens are 0 and the odds are 1. So then when I set up this Maclaurin series, I know that f of x, in this case, is going to be the hyperbolic sine of x, is going to be equal to, well, f of 0 is going to be equal to 0, plus f prime of 0, which is going to be 1 times x, plus f double prime of 0 is going to be 0 over 2 factorial x squared, and then f triple prime is going to be equal to 1 all over 3 factorial x cubed, plus, let's do one more, 0 over x to the 4th over 4 factorial, and then plus dot dot dot, we're going to have the eventh derivative is going to be 0 all over, it's going to be this over 2n factorial, because whatever this powers, remember what this is this is f to the 2n of 0 all over 2n factorial, x to the same exact power. And then we're also going to have plus, the next one, which is going to be 2n plus 1. It's going to have that same factorial on the bottom, and it's also going to have x to that same power as the derivative. Now, what we know is that f of 2n of 0 is just going to be equal to 0. And f of 2n of 0, this is going to be equal to 1. So what we're going to get here is 1 plus x cubed over 3 factorial plus x to the 5th over 5 factorial plus x to the 7th over 7 factorial. Just kind of using pattern here, plus dot, dot, dot. We're going to have this nth term, which is x to the, odd power all over that same odd factorial plus 5. Now, if I want to set up the hyperbolic cosine function, what I know is these are just going to be switched. So instead of it going 0, 1, 0, 1, it's just going to turn it around. It's going to go 1, 0, 1, 0. So if I want to do the hyperbolic cosine of x without going through the exact same work, all these zeros would now be 1s, and all these 1s will now be 0. So this is going to be 1 plus 0x plus 1 over 2 factorial x squared plus 0 over 3 factorial x cubed plus 1 over 4 factorial x to the 4th. And I'll even write these in this, and I'll simplify them. So plus dot, dot, dot. We're going to have, the eventh derivative at 0 all over that factorial that matches that derivative x to that matching power, plus the odd derivatives at 0 all over the same factorial x to that same power. Now again, remember all your 1s and 0s are switched, so now with hyperbolic cosine this will be equal to 1 and this will be equal to 0. So this will be equal to 1 and then this will be equal to 0. So what we're going to get is we're going to get 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial, x to the 6th over 6 factorial plus, and so on, plus only the even part, so x to the 2n all over 2n factorial plus forever. Now what I really enjoy about this is we know that the sine function, the hyperbolic sine, even the regular sine, is a odd function. So the hyperbolic sine function is an odd function, and what's nice is you can see all these odd powers being conserved, kind of verifying that this odd function through this power series. And the hyperbolic cosine is an even function. You can see that all these powers are even as well. So if you want to prove that f of negative x is equal to f of positive x, you could do it, really easily using these power series. So the last thing I want to do is I know that the hyperbolic sine of x plus the hyperbolic cosine of x is actually equal to e to the x. I'm going to show it using these. And then I'm also going to add these two power series and kind of verify that the sum of these two power series is also equal to the power series of e to the x. So leaving the hyperbolic sine and the definition of the hyperbolic cosine functions up here, what I know is I can add the hyperbolic sine of x plus the hyperbolic cosine of x, and we're going to get, this expression plus this expression. Okay. Now, adding these things together, what we know is we're going to get, just kind of write them as common denominators. We have e to the x all over 2 minus e to the minus x all over 2 plus e to the x over 2 plus e to the minus x over 2. And, simplifying these things, we can see that these will cancel. So what I'm going to get is I'm going to get 2e to the x over 2. Which is going to be equal to e to the x. So the sum of the hyperbolic sine and the hyperbolic cosine is equal to e to the x. Now I also know that if I want to add these two things, I could have done it in their power series as well. So you know that this is going to be equal to, with the hyperbolic sine function, it was x plus x cubed over 3 factorial plus x to the 5th over 5 factorial plus x to the 7th over 7 factorial plus, and so on, plus x to the odd power, so 2n plus 1 all over, I guess I'll do the parentheses, all over 2n plus 1 factorial plus and so on. And then I'm also going to add this to the hyperbolic cosine function, which is going to be 1 plus x squared over 2 factorial plus x fourth over 4 factorial plus x to the 6th over 6 factorial plus x to the 2n all over 2n factorial. Struggle with my 2's. Go in there. There you go. Plus and so on. Now when we add these things together, I'm just going to write them in ascending order. So first it's going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial plus, okay, I think we get it. Plus, what we're going to have is we're going to have I'll do the even first, so x to the 2n all over 2n factorial plus x to the 2n plus 1 all over 2n plus 1 factorial, and then forever and ever. Now what we can see is that the beginning part of this is clearly the summation from n equals 0 to infinity of, well, x to the n all over n factorial, which is what these things will actually condense to when you combine their even and their odd parts together. We get this, which is, in fact, e to the x. So again, if you like the content, please consider liking, subscribing, and sharing.